In chapter 6, we're going to start talking about systems of equations. First and foremost, what exactly is a system of equations? And then how do you solve them? Well, systems of equations are just more than one line. And we are very familiar with lines by now. We've been graphing lines and solving the equations for lines for a couple of months now. So the difference here is that instead of focusing on just one line at a time, now we've got two. And how do we solve these systems? Well, there are three ways. There's graphing, substitution, and elimination. So a system of equations is more than one line. And when we're talking about graphing systems of equations, a solution to a system is going to be where the lines cross. Okay, so when we're talking about two lines on the same coordinate plane, the first situation that we have here is that these two lines can cross once. Okay, and when we have two lines that cross once, they might be perpendicular or they might be skew. Miss Roback, what's the difference between perpendicular and skew? Perpendicular means that they form a 90-degree angle. Skew means that they don't, okay? So we might have two lines that are perpendicular or skew. Now, when you've got two lines that are perpendicular or skew, they're going to cross in just one spot, meaning that they will have one solution. Okay, and that solution is going to be the point where they cross. Now, you can always check your answer when you're graphing systems by plugging it back in to the original equation. Now, the second thing that could happen when we've got two lines on the same coordinate is that those lines could cross never, meaning that they are parallel. Now, when you have lines that cross never, and I'm telling you that the solution is where they cross, do you think you're going to have a solution? No. So there would be no solution to a system where the lines are parallel. Now, you can check your answer for this by simply looking at the graph and seeing if they have the same slope. Remember, parallel lines have the same slope. And then the final thing that can happen here is that we could have two lines that cross forever. Ms. Roback, what do you mean by two lines that cross forever? Well, if you graph your first line and it looks something like this, whoops, maybe if my pen would work. And then you go to graph your second line and it happens to be right on top of this one, that means that they are going to cross forever because they are laying on top of each other. So every single point will be the same exact point on both lines. Now, when this happens, that means that you have infinite solutions. This is the symbol for infinite. Now, when you have infinite solutions, I put the symbol here because I don't have a lot of space, but what I want you to write is infinitely many solutions. Now, the way that you can check your answer this way is to, well, convert one of your equations so that they are in the same form, and if they are the exact same equation, then that means that they are the exact same line. So to check, you would look at them and see if they are the exact same equation. So I gave you a couple of notes here to help you decide what kind of answer or solution you're going to have to these systems. We are talking about graphing. Graphing is the first way to solve. Now, I'm going to kind of go a little bit at a faster pace on this next page when I go through examples. And the reason for this is because you should be experts at graphing by now. And if you're not, well, it's time to maybe look back at a couple of videos or come to study tables or come see me for extra help. Because at this point in time, at this point in the game, you should be a pro at graphing lines. Okay, if you're not, chapter 6 is going to be pretty difficult for you. Okay, so with that being said, let's flip over. We've got our first example here. We've got two lines. Remember, I told you that a system is just two lines together. Okay, so we need to plot these two lines on the same coordinate plane and see what happens. Now, I'm going to suggest that when you're graphing, it's going to be a good idea to have two different colors. Do you absolutely have to have two different colors? No, I guess not, but it's going to be a little bit easier to see the difference between the two lines if you have two different colors. And, well, since Christmas is right around the corner, let's go with the green and red. All right, so this first one, I'm going to graph the first line in green and the second one in red. That way I can tell the difference between the two of them. So in my first line, let's just review this. Like I said, should all be review. Our y-intercept. This is in slope-intercept form, y equals mx plus b. Make yourself familiar with that. Our y-intercept is at -5, and our slope is negative. Remember, there's a coefficient here of 1, so -1, meaning rise -1 and run once, 1 over 1. Okay, so let's graph this. We're at -5 on the y-intercept. And then my second line I'm going to look at, and we've got a slope-intercept of -3. And our slope is, this is a coefficient of 1, so we're going to rise 1 and run 1. So starting at -3. So now we have graphed both points. And our solution, like we said on the front page, is where these lines cross. So that's going to be this point here. You just need to look and figure out what the location of this point is. And yes, you need to write it as an ordered pair. So to me, this looks like -1, 1, 2, 3, 4, -4. Okay, so our solution, our answer is going to be -1, -4. Now, remember, to check your answer, when we have lines that intersect, there's one solution. This would be it. And to check your answer, you're going to plug it back into the equations. Remember, if we're talking ordered pair, this is x and this is y. So you're going to plug in for x, -1, in both of these and check it. And then plug in -4 for y into both of these and check it and see if you get a true statement. Okay, so the first one was in green. Let's see, y equals, your y is -4 equals -1. Two negatives make a positive, -5. -4 equals -4. Does -4 equal -4? It sure does. So checked there. Let's check it in the other one. We have y equals x minus 3. Plug in x and y. Our y is -4 equals x, which is -1 minus 3. -4 equals -1 minus 3, -4. That one also works. Awesome. So we solved, we checked, it worked in both equations, so this is our solution. That is it. Miss Roback, do we have to check? Yes, I'm sorry, but you do. Okay, let's move on to the next one. In this line, again, I'm going to use my two colors. My first equation, my y-intercept. I'm going to go even faster through this one. B, slope, 7 over 3, rise 7, run 3. So go ahead and graph this. Remember, guys, if you are graphing and your slope takes you off of the graph, you can always do your slope in reverse, go down and to the left. Line number 2, we have a y-intercept of 1 and a slope of -1/3. So that means rise -1, run 3. So down 1 over 3. Now, where did they cross? Okay, let's check this into our answer. I'm going to fast forward for this part 2. Once again, like I said, you should be familiar with the fact that this is x and this is y, so plug it in. You guys know how to plug in numbers. So we checked it into both and it came out as true statements. Does 2 equal 2? It sure the heck does. So this is our solution and we checked it. All right. So number 3 and number 4, I'm going to skip. That's for you to finish. You can do them the same way we did number 1 and 2. On the next page, we have one more page. This is a 3-pager. Okay, so now the difference on this page is that are these in slope-intercept form? They're not. They're in standard form. Okay, now graphing in standard form, if you ask me, is a lot easier, I think, than graphing in slope-intercept form. It's just a matter of preference. I like graphing in standard form because I can just do my hideaway method where I cover up one part of it and solve for x, cover up the other part of it and solve for y, and those are my intercepts. So let's go through this real quick. Once again, please use 2 different colors. My first line, we have to do the hideaway method. So if I solve for x, I just have x equals -5. That's my x-intercept. Solve for y. This is -1y. So I need to divide by that negative. So that makes y equal to +5. So to graph this line, on my x-intercept, I go to -5. And my y-intercept to +5. Okay. The other line, let's do the same thing. Cover the y and solve for x. We've got 2x equals -15, so I need to divide by 2. Yeah, I'm going to get a decimal here. So when I divide by 2, I get -7.5. We can graph 7.5. It's between -7 and -8. And then solve for y. We have 3y equals -15. Divide by 3 and you get -5. Okay, so let's plot those 2 points and connect it with a line. So x-intercept at -7.5. 1, 2, 6, 7. Here's 8, so a half will be right here in between them. And then a y-intercept at -5. 1, 2. Okay, let's go ahead and connect these. Okay, and then here we have the point where they cross. I'm going to call that, let me see here, let me count. 6, -6, -1. Okay, how can we check to make sure that that's a solution? Plug it in. Okay, here we have x and y. All right, it worked out both ways, so this is a correct solution. We checked it. All right, one more, and then I'll once again leave the last 2 for you. Number 6, we have to find the x and y intercept in standard form. Line number 1, I'm going to go kind of fast through this. Solve for x, and you get -4. Solve for y, -4 divided by -4 comes up to be a +1. And then the other line, line number 2, cover this up, solve for x. 28 divided by 5 gives me 5.6, so just about 5.5. Can you get decimals? Yes, you can. The other one, cover the other side and solve, and you get 7. Okay, so we need to graph this. Positive 5.6, so just about 5.5. Should be like right there. And then y-intercept at 7. This time it looks like our lines cross here, and that point is 1, 2, 4, 2. Write it as an ordered pair. This is x and y. Check it into the equations and see if you get true statements. All right, worked out for both. So this means that this is our solution, one solution. Okay? Number 7 and 8 are going to be for you to finish. Don't forget about number 3 and 4 on the other page. So you have 4 left to finish graphing. Don't forget the summary questions. I'll see you in class tomorrow.